Yesterday we finished that is a graphical treatment of triangular. So today we will go through the analytical treatment of triangular. I have two vectors. Suppose this is vector A and we have another vector B, and they are at some angle. For example, at some angle theta. So I have to find the resultant of these two vectors using triangle of vector addition. I will take this vector A, and using the rule of vectors, I will take this vector B and put the tail of this vector B on the head of A, and this will be our vector B, and I will join this vector A with the head of vector B. Suppose this will be our resultant R. I will name it. Let me suppose this O, A and B. So here I can write that from graphical treatment that R is equal to A vector plus B vector. Now I will find the magnitude of this resultant vector R, and I will also later on find the direction of this resultant vector R. For this I will do one thing. I will just produce this vector forward, and I will draw the perpendicular on this vector. So here let me name this. Suppose this is C here. I will name this point C here, and also this is the angle between vector A and vector B. So here angle is always checked between the two tails. So this is the tail of this A vector, and this is the tail of this B vector. So this will be angle theta between the two vectors. Now I will take this triangle. I will take this triangle. I will take triangle ACB. So from triangle ABC, I can write cos theta. Cos theta will be equal to base, that will be AC, divided by hypotenuse, that will be AB. Since AC divided by, so AB is equal to B, and it is given that AC vector is equal to B vector, or I can write that mod of AC, that will be equal to mod of B, or simply equal to B. So AC divided by B. So what will be AC now? AC will be B cos theta. Similarly, I can find from this triangle ABC, I can find sine theta, or sine theta will be equal to, that will be equal to perpendicular divided by hypotenuse, that will be equal to BC divided by AC, which implies that our BC will be equal to B sine theta. So this side will be equal to B sine theta, and this AC will be equal to B cos theta. Now I will take this triangle. I will take triangle OBC. From triangle OBC, I will use Pythagoras theorem, and I can write that OB square is equal to OC square plus BC square. OB square, it will be equal to OC square plus BC square. Since we can see that OC is equal to OA plus AC. So I can substitute it here. So OB whole square will be equal to, that will be OA plus AC whole square plus BC square. Or OB is given, it is R square, is equal to OA plus AC. OA is equal to A plus AC is equal to B cos theta whole square plus BC is also, that is B sin theta whole square. So R square will be equal to, so I can use your formula and expand this, A plus B whole square, A square plus B square plus 2AB. So it will be equal to A square plus B square cos square theta plus 2 times AB cos theta plus B square sin square theta. So R square, that will be equal to A square plus, I can take B square common from these two terms. So it will be B square cos square theta plus sin square theta plus 2AB cos theta. So R square will be equal to A square plus B square, since this is equal to 1, this trigonometric identity, plus 2AB cos theta. So this will be the resultant R square, or I can write R is equal to under root of A square plus B square plus 2AB cos theta. So this is the magnitude of the resultant of the two vectors that are A and B. So we can easily find the resultant of these two vectors. I found resultant magnitude, that is r is equal to under root of a square plus b square plus 2ab cos theta. Since we know that we have two vectors, we are adding these two vectors, so we got a resultant r. But this resultant is also a vector, so it got magnitude, it got direction. So I found magnitude, that is under root of a square plus b square plus 2ab cos theta. Now I'll find the direction of this resultant vector. I'll find direction. So how to find the direction? Direction of a resultant we can just check out how much angle it makes with either of the vector. Suppose this vector A, and let me suppose this makes an angle alpha. So I can check the direction. For checking the direction of a resultant means to check the angle, how much it makes an angle with either vector, whether A or vector or whether B vector. So let me suppose it makes angle alpha with the A vector. So I can find now tan of alpha from this triangle. So tan of alpha from triangle OBC. I will find tan alpha. So tan alpha will be equal to BC divided by OC. Since BC is equal to B sine theta and our OC is equal to, it will be OA plus AC, but OA is equal to A and AC is equal to B sine theta, B cos theta. So our tan alpha will be equal to B sine theta divided by A plus B cos theta, or alpha will be equal to tan inverse B sine theta divided by A plus B cos theta. So this will give me the direction. So I'll find angle alpha. So alpha will give me the direction of the resultant r with respect to this vector A. Or I can similarly find other angles. Suppose if it makes angle beta with a B vector, so I will find beta from this triangle. So easily I can find the direction of this resultant r. So we got magnitude and we got resultant. So this is the analytical method of the triangle. So in next video, I'll be dealing with the cases, special cases, and we'll go further on.